Hello, how are we doing? I'm just waiting to check that this has actually gone live into the Facebook group so that people can join in. Yep, there it is. And I'm going to open it up. So if you have any questions as we go, you can add them, or if you want to join in, comment as we go. If you're watching this after the lesson or on the different platform outside of the Facebook group, you can still comment and I'll still see it and reply. It just obviously won't be live, but you will have the bonus that you can pause the video and go at your own pace if you need to as we go. So today, what I'm going to do with you is some key geometry terms. So hopefully you can see, oops, press the wrong button, didn't I? Hopefully you can see Bitmoji me there. There we are. That works. So there's quite a few separate things in the geometry topic. So I'm just going to start with some of the key terms for today and then go through the rest of the stuff in later lessons. So these are the terms that we're going to cover, what they mean and when you would use them today. Hopefully that's stuff that you've seen before, but if it's not, that's absolutely fine. We're going to put some definitions to them today, so you can make some notes to use for your revision. So the easiest way to highlight them is with an actual shape, unsurprisingly. And I'm just going to get the spotlight so you can see that moving around. Just going to double check that that's shown up correctly for you. There it is. You can see a little red dot moving around the screen, which is currently in the points box so that you can find it. Okay, so points on a shape. Points can actually be anywhere on the shape, the same as if you were picking out a point on a map. Literally, the fact that you have highlighted it is what has made it a point. So it can be any part of the whole shape. So wherever this is, but because this is a 3D shape that we've got here, it can be any point in that depth. So if I've highlighted there, I'd have to specify where it's in that depth. And quite often the way that we would do that is by giving a 3-figure coordinate. So if you've done coordinates before, you might remember them as an X and a Y coordinate. And then on top of that, you also have the Z coordinate. So that's its depth in the shape. Yeah, so you can give a specific coordinate as part of the shape to define a point, or it could just be labelled on the shape as a point. Lines are a bit more self-descriptive. So each of these black lines in this shape are the lines of the shape. That's a nice easy one. The vertices are the points, so the corners of the shape. Yeah, so that's a vertex. That's its singular, vertex, and plural, vertices. So each of these corners is a separate vertex. They're all the vertices of the shape. The edges are, in fact, again, the lines. So each of these have an edge of the shape. Okay, and the planes is a little bit more confusing to define. So I've put that on a separate page there. So in maths, the definition is that a plane is a flat, two-dimensional surface, so like a sheet that could extend for an infinite distance. So same as like coordinates, if you can see from the example, it's similar to a coordinate, but it's not coordinate as in the axis, it's the whole plane on that axis. So it says it's a two-dimensional analog of a point, specific point, a line, and a three-dimensional space. So it is essentially making this a sheet. So hopefully that makes sense. So that was all of the terms that we needed to define. If any of those don't make sense, do ask, or if you would add anything to those definitions, go for it. So there's some examples that I took here from maths worksheets for kids. they just kind of show the way that they might be demonstrated in an example in a question. So point, just a geometric element with no dimensions, because it's literally just a point. Even the dot that they've drawn to highlight that point is bigger than the point itself. It's a very specific part of a shape. It can be given it could be illustrated with a dot and a label, and the symbol it's given is the name that it's given. So it's labeled given whatever definition you've given to that point. A line is just a collection of points along a straight path. So we know how we would draw a line. This is just defining it mathematically, and they usually, so it doesn't have to have an end point, but it often has labels on it. So this is an example of how they've labelled that line A to B, but it does actually just continue like an axis, continues infinitely. A line segment is part of a line containing every point between them. So these are all separate points combined in a line. It is just a straight line. That's making it sound more complicated than it is. It is just a straight line. And ordinarily in a maths question, this is the example you'll see labelled one end to the other, not a line like this. Okay, the line segment is the way that things are usually represented in your maths questions. And that's illustrated the same as this. Or potentially that would be how you would see a vector. Array again looks like a vector. Usually the definition ray you would see in a physics exam, but it's the same as a line but with a specific direction, so a vector. And then we looked at plane before, but this is an example, and you can see that in that plane several points have been labelled. So those points could be used to define that plane as the two-dimensional surface that those are all contained within. Now that probably sounds more complicated than it actually is, because I think you've actually probably seen all of these things and used them, but potentially not given that much thought to their definitions or the ways that they're different from each other. So I'm sure you'd be comfortable with what each of those things are. Try not to overthink them. What you would have to actually do with them, you would do fine just by understanding the differences between them and not by actually having to define them. So there's some notes that cover that in more detail at the Maths Made Easy site that I've linked here. So on the website you've got GCSE maths revision pages, lots of maths revision pages. If you search for 3D shapes, you'll see those definitions and some practice questions. And the ones that I have, I pressed the wrong button there and started playing my music. Questions I've got for you. Confused me. Got for you here and here. Right, the 3D shapes, faces, edges, and vertices. Let's have a go at some of these. So we've got some examples of some 3D shapes here, and hopefully within those you can see that they're quite familiar shapes. You might necessarily be comfortable with remembering all of the names straight away, but you have probably seen them all before and recognized them. And you can see that they demonstrate some of the things that we've been looking at the definitions of just there. So with a triangular prism, you've got a vertex at the top here. You've got a plane with flat surfaces on. You've got edges. Yeah, so you can see these things here. The cube is the same one, so that has all of them. Yeah, I'm only just seeing that these names are not matched up. I'm thinking that's not a sphere, they're not matched up. This one's got all of those in. There's cone, sorry, you think it because it's there. The sphere here, not so many, pretty much just the surface. It has no vertices, no edges, no lines, no faces. Well, one single face. So hopefully you're comfortable with these shapes. The question is asking you to match each shape with its correct name by drawing a line between them. So let's have a go at that. With my tablet. So the first one, like that. first one in there, this shape is a cone. We can match that up to the cone. This one, the same one as was in the slides, this one is a cube. This one here, just an extension of a cube, it's called a cuboid. Our globe here is a sphere. This one is a pyramid. We've got our triangular extended prism there. So a prism is in a 3D shape. So this would be like a square prism, but we don't call it that. We call it a cuboid. It's just an extension, a 3D extension of the 2D face as a prism. And then we've got a cylinder, which is a circular prism. That one again has its own name. So hopefully you're comfortable with that. Have we got something? No, that's it. Okay. Oops. Scroll. Okay. We've got some examples of some shapes to start using these terms with. So it wants to know the number of faces, edges, and vertices of each of these. Okay. So for faces, it's just each surface. So because that's a cube, we know that a cube has got 6 faces like a dice. So front and back, left and right, top and bottom. That's our 6 faces. And edges is each of the lines. So you can draw one to see how many edges it's got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's our cube, 12 edges. And how many vertices? That's each of the corners. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. So you don't necessarily have to remember these. You just have to remember the shapes, and then you can count the properties. And similarly, we have a triangular prism. To see how many faces does it have? So front and back, bottom and 2 sides. That's 5 faces. How many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 edges. And how many vertices? So we've got 1, 2, 3, 4, 5, 6. So you can see a pattern with these extended shapes. You've got the number of vertices is really double the number of corners in the shape on the face of it, because it's just that extended into another at the back. So you have those vertices repeated at the back. Okay. Give the number of faces, edges, and vertices of the following shape. So that rule doesn't work for this one because it's not a mirrored shape in a prism. It's like a different type of 3D shape. So how many faces do we have? We can count them again. So we've got front and back, left and right, and the bottom. So that's 5 faces. How many edges? Oh, I'm not annotating. How many edges do we have? So we have the 4 around the square base, 3, 4, and then the 4 that make the pyramid. So 8 edges. And how many vertices? So mine isn't very good drawing there. So I'm going to use theirs to count the vertices. So we've got 1 here, 2, 3, 4, 5. That's our vertices. Okay. Hopefully that's making sense where I'm getting all these numbers from. This one's a bit different, right? So this is a sphere. It only actually has 1 face. It doesn't have any edges, and it doesn't have any vertices. It's a completely smooth shape. So we can put 0 for there. I don't know why I've opted to do that with my mouse, but there we go. That's what we have for those. And then this one, what have we for there? That is that face is a trapezium, and it's a prism. So it's a trapezoidal prism, which is a fun one to say. You don't have to remember that one. I don't think I've ever seen that one come up. I was like, what is it called? But the number of faces, again, how many faces does it have? Front and back, left and right, top and bottom. Same as a cube, just differently shaped. So it's got 6 faces. How many edges? So we can count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That looks right. And how many vertices? Count the corners. 1, 2, 3, 4, 5, 6, 7, 8 vertices. Okay. Same for this one. How many faces does this have? So we've got the bottom. This one's a cone. So all of this surface is one face. It's just a curved face. Yeah, so it's only actually got 2 faces. How many edges? Just this one edge around the bottom and just one vertex. So not much going on in our cone. There we are with those. I hope that makes sense as you're going through those examples. If we go back to the slide, I don't know why if I press on that keyboard it starts playing my music again. It's nice, but yeah, that wasn't what I was asking it to do. There we go. These are the key points that we needed to understand the definitions of for the lesson today. So we want to know what a point refers to on a shape. Remember that was just a space within anywhere within the shape. Any point that you've selected within that space, as long as you can define it, that's your point. The lines make up essentially the edges of the shape, but you can just draw a line stand alone within a shape and define that separately. The vertices are the corners of the shape. The edges are the lines that define the boundaries of the shape, and the planes are quite often the faces of the shape, but they can be standalone, just a 2D surface that extends infinitely, so it's not necessarily just the face of the shape that defines the plane. It goes on beyond that. I hope those make sense. I know some of them are a little bit bizarre and potentially things that look much more confusing than they are and are actually quite familiar. So I wanted to just do these points in isolation today, just to make sure that it didn't get confusing. What I'm going to go on and do the next time are some other points, other key terms separately. So parallel and perpendicular lines leading into right angles, and then polygons, reflections and rotations, which is building on this geometry idea. And it will use these terms again, so I wanted to make sure that you were comfortable with those. If you have found this useful, as always, I'd be grateful for a review or recommendation. I believe actually that Facebook has turned off reviews on the page as they were, but you can still leave a recommendation and that's much appreciated. If you find the resources in this group useful, I'd love it if you could recommend it to any friends you know that are going through their GCSEs at the moment. And if you need any additional support with preparing for your exams, send me a message to book some one-on-one tuition. So those slots are starting to book up now for September starts. So if you're looking to book for the next school year, I'd recommend getting in touch and booking your place early rather than wait until September. I hope that's helped today. As always, if you have any questions or if anything doesn't make sense, send me a message, and if there's anything that you would like covered, I'd be happy to hear from you. We'll make sure that appears in the next lessons. Have a good week, and I'll see you again next Thursday.